Okay, this is 14.8.8, and this one involves finding integers that sum to 48, and in addition, that they have the largest possible product. So once again, this is a maximization. We're going to maximize the product of the three numbers, and we want to do it such that their sum is constrained. They can only add to 48. Because they're positive, I won't have to consider negative possibilities, and of course, none of these will have the largest product if they're 0, so that bodes well for the simplicity of this one. Okay, so first we need a product equation, so I'll just call that f. So f of x, y, z, so I have the order for the partials, is going to be x times y times z. And then the constraint equation is going to be g of x, y, z, and that is that their sum is 48. So that'll be x plus y plus z minus 48 equals 0. So there's the two functions. Once again, I'm going to build my equations fundamentally by using a Lagrange multiplier. That is, I want to set the gradient of f equal to the Lagrange multiplier times the gradient for the constraint. And then that's going to give me three equations with three unknowns, and then the constraint equation gives me a fourth equation so that I'll be able to handle both lambda as well as x, y, and z. Okay, so let's go ahead and build it. First, the gradient of f, and that's going to be pretty straightforward. That's going to be the vector yz, xz, and xy. And then the gradient of my constraint function, and that's going to be 1, 1, 1. Okay, this produces a pretty easy set of equations with the Lagrange multiplier in it, and that is that yz equals lambda, that xz equals lambda, and that xy equals lambda. Well, once again, we've ruled out the possibility that any of these could be 0, and that's good. That means I can divide by them. So that means yz equals xz, or that x equals y. Further, that xz equals yz, so that z equals y. So I get the condition from the Lagrange multiplier that these all have to be equal to each other in order to achieve this. And of course, the constraint says they add to 48. And the three integers that add to 48 are 16. So x equals y equals z equals 16. And that produces the largest possible product. So f max will be equal to 16 cubed. So those are the integers, and this is the maximum product they have so that they meet this condition. Now, just reading the question, you probably could have come to this conclusion that basically you want each of the integers to be as large as possible and add to 48, and as large as possible means they're all as big as possible while still doing this. So you probably could have logically concluded this, but it's nice to see that the Lagrange multiplier method works with easy problems, because most of them you won't be able to tell what the answer is by inspection.